Hi again, welcome back to the LilBUBome video log, where today we'll show you a first glimpse of what Bob's DNA sequence looked like when it initially came off the sequencing machine. And so last time we left off having prepared Bob's DNA and loaded it onto the sequencer. And once we started the machine, we first had to wait a couple of days for this to happen.
You've got mail.
When the sequencing facility emailed us to let us know that Bob's sequencing run had completed and that data was available for download. And this is what the data looked like at its first instance. A couple of so-called fastq files which have been compressed because they're so big. And the reason for having multiple files is that we had made two preparations of Bob's DNA where we cut it into different size fragments and we sequenced both ends of these fragments. And so we have separate files for the two DNA preps and for the different ends. So what exactly is inside one of these fastq files? Well, let's take a look. In essence, fastq files are text files, so you can just open them with any text editor. And as you can see at first glance, they just appear like a bunch of jumbled letters and characters. But if you know how to read them, fastq files are actually a treasure trove, because they contain both the raw sequence information for the millions of reads from Bob's genome, and also additional data. Most importantly for us, they will tell us about the sequence quality. So the way to read these files is that every single fragment that we sequence is represented by 4 lines. So this here would be the first fragment, the second fragment, the third fragment, and so on. And the first line, the one beginning with an @ just tells you technical information, which machine you were using, what fragment you're looking at, and so on. The second line is the one with the actual sequence data. So this here will be some combination of A, C, G, and T, and occasionally N at the positions we're not so sure about. The third line is simply a plus symbol. And the fourth line is the one that gives you the quality score. So every single character you see here corresponds to the letter in the second line. So A gives you some quality confidence about this T here, this A tells you something about this C, this E tells you something about this C, and so on. Now, every single one of these characters first can be converted into a number, and that number can then give you some kind of indication of how certain you are that this letter here is correct. The system of converting it is relatively complicated, so we won't go into detail in the video, but we'll post a couple of links, so if you're interested, you can read up on it. Kind of as a rule of thumb, E's are really good values. So all the sequence here that has an E as a quality score, we're pretty certain is correct. A's are okay, but not as good as E's. And then these weird characters like the slash and the smaller than sign are not so good anymore. And hashtags are like really bad. That's why you can see all these N's here. Obviously, since we have millions of fragments, we can't go through them one by one. And therefore, we need various programs that help us transform these fastq files into something more manageable that we can easily analyze. And in our next video, Dario will tell you more about these programs, so stay tuned.